So hello everybody. Another one of my chaotic live streams. And I think we should get started. Okay, maybe that was not the best music choice, but oh well. It's always hard to find free music for these things. Switching to the monitor. Hi guys. Not sure if anybody is watching. Probably not. Probably the stream will be watched during the week. My channel is small and insignificant. So what I'm trying to do today is to finish a small CW Keyer project. And it's based on the ATTiny CW Keyer. Maybe not directly from Don Fruula, but he was, I think, the last one who dabbled with the code. And so that was the latest version of the source code that I could find. It's basically using the YACK CW library and just an ATTiny85. Let's have a look. Do I have the schematic? No. Here, the schematic. So as you can see, maybe let me get out of the way. Maybe like this. Okay, now you can see the schematic. And now I just need to find the right window to be able to draw in there. So yeah, nothing really special. Tiny AVR microcontroller, 8 pins. As you can see, let's see, can I draw here? Yeah, I can draw here. So this is basically the output section, just the NPN transistor, I think, connected to the GPIO output. And this is where your transceiver is connected to. And here we have a small buzzer for the side tone. A button to get into command mode or control mode. And then you can use the CW pedal to key in commands. So basically you can even, I think, have, pre-programmed CQ messages and so on. And when you press the button and then key in a specific character, then it will play the pre-recorded messages. Basically you can control the whole thing via CW when you press the command key. So that's all very nice. The only problem that I think some people have with these things is you get a 8-pin microcontroller, and if you do not buy an AVR programmer or have one in your drawer at home, then programming this thing is a bit tricky. So I thought I'm clever, and I probably was not so clever. And I get one of these small Digispark boards, which is more or less exactly the same AVR microcontroller, but it has a different bootloader, and small bootloader makes it possible to load the firmware via USB. So you connect this thing to your USB output, USB socket, and with the Arduino IDE you can basically program this thing. So far so good. The tricky problem comes then when you realize that, hey, this thing really only has 8 pins. And of course the 2 pins that are needed for the USB connection are then 2 GPIO pins that you're lacking for your CW software or for your CW Keyer implementation. But I think I managed to get it working. So let me show you how I did that. So we've already looked at the schematic here, and somewhere I have the schematic of the Digispark here as well. So here you can see, let me scroll down, schematic of the Digispark, and as you can see, here are 2 of the GPIO pins are connected here to the USB port. 1 second. And the tricky bit here is that here they are using 2 Zener diodes to basically get the 5 volt of the USB port to the right level for the USB D plus and D minus. So here is a Zener diode, 3.6 volt Zener diodes that get the USB D plus and D minus to the right level. And then you have the obligatory pull-up resistor, probably to indicate it as a low-speed device. I have not checked. But basically, this is how classic USB determined whether a high or low speed device is connected. You basically have a pull-up on either the D plus or the D minus line. And as you can see, this is all hooked up here to the ATTiny. And then when we want to add our CW Keyer schematic on top, you somehow have to make these two things coexist. And I think I managed to do that. At least it's working on the bench. And what I try to do today is basically to finish the soldering job. But before we do that, let me quickly show you how you get one of these Digispark boards, how you can program them in Arduino. So let me see, do I have... Yeah, so basically you get them everywhere on eBay. I just basically opened ebay.com, typed in Digispark, and this was one of the first links that came up. So they're dead cheap. And in hindsight, I probably should not have started this project in using the, well, maybe fairly old ATTiny85. I should have used Raspberry Pi Pico RP2040. Much more GPIO pins, much more processing power, and from a price point of view, there's almost no difference. So, yeah, well, I got this thing in the mail, and then I had to, you know, pull through, right? So you can't buy these things and then just throw them in the parts bin. So, yeah, let's finish that, and maybe I'll get a Raspberry Pi Pico later as a comparison project. Okay, so how do we program this thing? As I said, the idea is you use the Arduino IDE. You just connect this thing to your USB port, and then you can program it. So how does that work? Let me, here I am already. So Arduino IDE. You go to File Preferences, and then there's a link here below where you can add additional board manager URLs, and you insert this URL, github.com/spence-conde ATTiny and click OK. And after you've done that, you should here under board manager, you should be able to find the ATTiny core. Let me see. I can find it. On this machine it's not installed yet, so I can basically show you live how it is done when it's probably contributed, or I don't know. Partner? Yeah, of course I don't know what type is, but let me just scroll down. It should, in theory, show up here somewhere. Here, let me... No. Okay. I'm probably looking for the wrong string. Let's try again. See, that's the show effect if you're not... ATTiny core. Yeah, so I guess this thing should be called ATTiny core. Maybe with a wildcard. Nope. Maybe it didn't load it. because I'm not sure if this is the latest IDE. Let's see. Maybe I have to restart the IDE once for it to pick up. Let's try that. 1 second. Just want to show you how you install the software and get your Blink sketch going, and then we go to the bench and I start the soldering fun. Where is my Arduino IDE now? Here. And here it comes. Second. Nope. Bloody hell, it doesn't show up. I'm pretty sure it worked on my laptop, but this is a desktop, which behaves, of course, completely different. Aren't computers fun? I've probably already missed it twice by looking. Let me get my short-sighted eyes close to the monitor. Quickly get rid of the video. It should be definitely under Board Manager and not under Library Manager, but I'm not seeing it. Interesting. Is this the latest IDE? That's the question. Let me quickly have a look, because I just updated it right before the stream. Big mistake. Yeah, 204 should be the latest one. Not sure why it's not taking. Maybe the URL is wrong. Let me just Google for ATTiny core. How to install ATTiny core. See. Oh, yeah, the URL is wrong. That's why it doesn't work. I remember I used this one. Okay, so all my fault. Forget that one. Use this one, which is a JSON file, which probably points to the exact same Git repository I just had in here. And here it shows up. See, if you use the correct URL, it shows up. ATTiny core by Spence Conde, version 152. Click install. Yeah, of course, that is the install prompt. And I hope it doesn't interrupt my stream. It also comes with the nice non-signed driver pop-up. But we go full risk, and at the end you see that here it installs libUSB for the Digispark and everything that is needed to basically program the Digispark board. So now it's installed, and now under Tools you should be able to select the board, and you go to ATTiny core and select ATTiny85 micronucleus Digispark. And then under Programmer, you can also select micronucleus. And this is more or less already everything set up and ready to program the Digispark board. Let's see, example sketch, see if it compiles. Go with the blink example. And then say verify. And as you can see, the compilation works. My Digispark board is currently at the bench already programmed, so I'm not showing you that. But after you've set it up like this, you should be able to upload the Blink sketch, and it works a bit different to a regular Arduino Nano. Basically, you have to press the upload button, and then it tells you here in the output window, now insert the Digispark USB connector, and then it should load the software. So maybe quick summary. Using this URL, which is the correct one, put it in Board Manager, then under this icon Board Managers, you will find the ATTiny core. Version 152 at the moment. Then under Tools, select Board ATTiny85 Micronucleus Digispark. Under Programmer, select Micronucleus. And I think you can even update the bootloader via USB to a later version. But of course, if something goes wrong, you're again in the position that you need an AVR programmer. What else do I have to tell you? Yeah, maybe before you do anything else, set the clock here to 1 megahertz, because this is how the ATTiny CW Keyer project is set up. It is running the AVR at 1 megahertz, and all the timers are basically based on that. So from the 1 megahertz CPU clock, it divides down to a 5 millisecond or roughly 5 millisecond system tick. And with this system tick, it does all the tone generation for the side tone and the counting how much words per minute, etc. So you need to set that to 1 megahertz. Okay, so that was that. Guess we can close this now, and this window as well. And we're already running 20 minutes, and we haven't even started with the soldering fun. Okay, yeah, so the catch is, of course, at the moment, let me switch the video back on. The catch is, of course, that this software here on this branch is not for the Arduino IDE. So I've already forked it. And if anybody's interested, I can upload basically the Arduino Sketch version of this software, and then it's simply a matter of downloading the code, unpacking it into the Arduino workbook directory, and then just hitting basically program, and then you should be able to write it to the Digispark. Okay, so that was the theoretical part. Now let's go to the bench. And for that, I have to first switch microphones. Okay. Oh, that's a bit noisy, isn't it? But I think it's working. Okay, so headphones off and to the workbench. Okay, and I have a real mess here because everything took longer than I thought, as I've already explained, I was a bit naive with this USB flashing thing, and I didn't think it would interfere so much with the normal operation. But as you can see, we only have 8 pins, so let me get all that out of the way. So this is the super ugly prototype. As you can see, I more or less just soldered the Digispark on a little development board, and then I put the buzzer on, and then I've already prepared a few connectors here. But if you see at the bottom, there's nothing properly wired up. It's all just free flying around wires, because I had to get it going. So I can, at the moment, it's powered by 3 volt, and I can show you that it works in principle. So we have the DITs, and we have the DAS on the other side, and when you press both, so as you can see, in principle I got it working, but there's a bit of, well, small trickery needed. And yeah, as I said, I thought it would be a simple, you know, done in one weekend job, and now it's already 3 weekends. But hey, sometimes things take longer. Good. So what I'm doing next is basically desolder all this mess and then properly wire it up. And as you can see, I've already prepared here a few jumpers, and the reason for that is that once we connect our pedal here, basically we have extra components on the 2 pins which are used for USB flashing. So since I'm still in development mode, I decided I'll just put 2 jumpers here so that I can basically remove the jumper and flash a new software, and afterwards I just put the 2 jumpers back on and we are back in business. Yeah, and that jumper here, I don't know what's the reason for this one. Not exactly sure. See, it's already lying again on my bench for a week, and I forgot what I wanted to do. Maybe for adjusting the volume, right? I think that was the thing. Because this is now running at 3 volt, and the buzzer is not very loud, but when I crank up the volume to 5 volt, it's getting a bit annoyingly loud. So I thought I'll put a small resistor in line with the buzzer, and then I can short it with the jumper to reduce the volume again, or to reduce the volume when I'm running at 5 volt, and basically short it out when I'm running at 3 volt. Not sure if I even need the buzzer long term, but okay. So I need something to hold the PCB. I don't think anybody is watching this here. Doesn't look like in the chat, but yeah, it's anyway a super fringe project, because if you have a halfway modern transceiver, IC 7300, IC 705, even the true SDX, you don't need a circuit like this. This was again a clumsy attempt to, well, motivate myself to do a bit more with CW, because I'm still failing miserable in learning and practicing. So I thought a small project, soldering project, to motivate myself. And the idea is, of course, to maybe put it in a small 3D printed case. And oops, you can't see anything like this maybe. Is it focusing? No. Let's see. Yeah, looks Looks like it's focusing. Okay. So what did I want to say? Yeah, the idea was to put it in a small 3D printed case and put it next to my refurbished TS50, which does not have a built-in keyer. So if you have a very old transceiver, then maybe this is a project for you. But well, if you're really into ZW, you probably have a you don't want a small device like this. You want a fully fledged, maybe Arduino based keyer with lots of knobs and options. Okay, so now I have to clean up the mess that I've created here. Oh God, what did I do? This is not good, and I think it's also a wild mixture of leaded and not leaded solder. So I think we have to clean this up first. Give it a bit flux here and clean it up before we start the wiring. So, and then I think, yeah, 360 degrees should be enough. Maybe just wick it here up a bit with the solder wick. So yeah, I don't know. I really cannot, with good consciousness, today in 2023 recommend you to buy an ATTiny board. As I said, when a Arduino Pico is exactly the same price and gives you much more GPIO pins and possibilities, but well, you cannot say it's what do I want to say? You can't say it's yeah, over dimensioned. So this thing has 8 pins and all the pins are used, but if it had like, I don't know, 10 or 12 pins, then it would be much easier to do the job without extra jumpers and a bit of trickery. Okay, so this is all just clean up from my experiments. I had the wires directly connected. The camera focus, yeah. Okay, and now I need a bit of alcohol to clean it off. And as you have seen from the schematics, there's really nothing special on here. It's basically, most of the thing is wiring, a few capacitors to ground, and yeah, in order to make it work on the Digispark, I needed one extra pull-up resistor, external pull-up resistor. But that one might also not be required if you're running it at 3 volt. So the reason why I need it is because of the Zener diodes to ground, these two 3.6 volt Zener diodes. Because if you use the weak internal pull-up of the AVR and you have the 3.6 volt Zener diode externally, then it basically, the pull-up is so weak that your voltage drops, and the end result is that the AVR thinks the button or the keyer is permanently pressed. So you need a bit of a stronger pull-up due to the Zener diodes. But of course, if you're running at 3 volt, then this 3.6 volt Zener diode won't pull your voltage level down. So maybe you can run it without the pull-up. So yeah, it's a bit of a big it's a bit of a compromise, yeah. So the convenience to easily flash it with a built-in bootloader gives a bit of penalty in user handling. Oh well, it works, it'll do its job. I think, let me see, I've also measured the power consumption. So it took about, at 3 volt, it took about 4.7 milliamps in idle. Then this thing can also go into sleep mode. Only, well, of course, the green LED of the Digispark is always on, so that takes about 3.3 milliamps. And with the buzzer going, something about 25 milliamps. So it's not super high power, but it's also not super low power. So I think with 2 1.5 volt AA batteries, you can probably have 1 or 2 happy days using it, which should be good enough, I think. Or you hook it up to the same power source that you use for your transceiver, then it's no problem at all. Good. So, what do I want to do? Let's see. I need to look at my schematic. And basically I have the pedal on PB port bit 3 and 4, which is the same bits that I used for USB D plus and D minus. So basically, first thing I have to do is go from these 2 outputs here to my 2 jumpers. Let's see. I need some wire. And then I need to see what is 3 and 4. Okay, you cannot use PB5, by the way, which is maybe something you can use when you get an authentic original Digispark, but most of the things that you find on eBay are clones. And the PB5 is usually the reset pin, and you can configure the reset pin as a GPIO, but you can also only configure it when you connect the AVR programmer and change the fuses of the AVR. So again, that more or less defeats the purpose of using the Digispark with the USB connection if you anyway need a programmer to change the fuses in order to enable the reset pin as a GPIO input or output. So basically PB5 is already not usable, yeah? So you have PB port 0, 1, 2, 3, 4, and these are the pins you have. 2 of which are more or less shared with the USB. Yeah, you need one for the button, one for the buzzer, one for the output, and then they're all gone. So this thing is completely utilized. Good. So let me put PB4. Yeah, okay, maybe. And since this is a one-time build, there's also no point in creating a PCB. Of course, you can use something like Digispark PCB, create a nice PCB, send it off to GLC PCB. But I think this might be the one and only CW Keyer I need to build in my life. So let's make this a one-time project. The cat has also shown up. Oh, it's not so easy to I think that was a bit too long. So maybe like this, and then bend this the other way and connect it here to the jumper. I have one eye on the chat, but I don't think anybody is watching. But I already knew that it would happen, because who builds a CW Keyer in 2023? You must be a bit strange. So my plier is also already knackered. I think I used it on something I should not have used it on. So I'm not doing a very good job here, I must say. Now it's too short, see? First it was too long, now it's too short. Bummer. So this is either the boring or the interesting bit of the stream. Good, so that was one pin to the jumper, and now the other one. Yeah, maybe I should bend it on the board to get the length right. So maybe here a bit. The good thing is I'm not watching any news when I'm here in the lab. It's a bit depressing at the moment. Anyway, I'm not watching a lot of news anyway since COVID. It's just self-care. Maybe once per day in the morning is good enough. So let's see. It's not super pretty, but it doesn't have to be. So I could use a bit of flux. Flux always helps. As you can see, I haven't even drawn the schematic on a piece of paper. Just winging it. Pretty sure I create a short here somewhere, because the ring light is in my way, so I'm not really seeing what I'm doing. Yeah, I still haven't got a small USB microscope for soldering. At least for SMD, that would be handy. So, and we've completely fried and knackered everything. No, maybe good enough. Okay, so that were the two pins for the pedal that are now connected here to the two jumpers. And if my mind serves me right, we need now two 10 nanofarad capacitors to ground. So where do we put those? Maybe, I don't know. If I let the ground run here on the outside, or at least here. No, the ground is the middle here, isn't it? Yeah, the idea was basically that these three pins are for the pedal, so maybe ground in the middle and then left or right, or ground on the left side. Don't know. And then we could put the two capacitors, I don't know. It's a bit try and error. Come on. We could put them like this and have the ground. Or like this. Is that good? Sure. Or one down. Maybe like this. Then they are sitting exactly next to the connectors, and I make the middle one ground. Yeah, I think I'll put it in like this. And maybe so that I can read the values after I solder them in. Okay, let's do it like this. Yeah, as you've seen, I was 3 weeks more or less completely off from my YouTube channel. I got some infection 3 weeks ago, and not so bad, just annoying. And yeah, once it was gone, I had a cough that took another 2 weeks to disappear. Not corona as far as I could see. I did the testing, but if you're coughing every 2 seconds, it's not good to film any videos. So, and now it's completely wonky. Come on. This is a botch job, isn't it? Oh well. I was more careful with my TS50, but that one cost a few bucks more than $4 or $5 on eBay. So come on, sit flush to the PCB. You okay, so and bad soldering job. Not enough solder. Better. Okay, so then okay, let's finish this section. We need to hook this up to the other side of the jumper. So let's see. It's not good. Sorry, I have to pick this up and put it close to my short-sighted eyes to see what I'm doing here. Maybe like this. Let's try this. Maybe a bit shorter, otherwise I'll have a short. Hot. Should not hold your wires. Ugh. This soldering tip is also at the end of its life, but see, cut it here. Yeah, this is it's all one big botch job. See, manually making it up as you go along has disadvantages. Ugh. Yeah. Yeah, let's see. Everything floats away when I come here with my solder, whatever you prefer. Yeah, exactly. As I said, it floats away. This is not good. Maybe I should have done it with enameled wire. See, now it's completely out of place. That's the problem. Okay, let's start again. But since nobody's watching, I can make a fool of myself as much as I want. Come on. Can't be so hard to solder a small wire, huh? So. Second try. It's good that we are only frying in the area with the jumper and the capacitor, so nothing to destroy. Okay, too much. But it looks like everything is at the right position. Good. Don't think about it. Next next wire on the other side. Yeah, I've looked at the source code of the YACK library. Actually, it's quite nicely done. I just had opinions about the code formatting, but after a few years, every programmer develops opinions about code formatting. So basically I just reformatted it to my liking, like consistent use of spaces and not a mixture of spaces and tabs, and always use brackets, no single line ifs with the command after the if without an extra bracket and so on. So I don't know. But anyway, while doing this, I looked at the code. It's actually, I think it's okay. It's fine. So now we need, what do we need? So we need these two pins connected in this. So basically we need just a 90-degree wire here. Yeah, maybe like this. Okay. So what time is it, by the way? Okay, stream's running for 1 hour. I don't know. Should I stop it? Should we just keep going? Pretty sure we won't finish this tonight because the whole software still has to be polished a bit, and then I can upload it to GitHub, but I don't know if anybody's even interested. So the question is, how much effort should I put in? Yeah. Okay. I have to clean this all up from flux residue. And where is the ground? I think I should put the ground connection maybe just run it straight here around the corner. Is there a shorter way? Not sure. Yeah. as expected. If it smells like chicken, you're holding it wrong. Is my audio even still running? Yes, it is. Good. See, that's why I put in this audio visualizer in the bottom left corner. Because when I'm sitting here at my bench, I have no idea if it's still working. Yeah, now everything is floating away. Yeah. I'm using too much solder for these kind of operations. So that was our ground for our pedal center pin, making its way slowly to the side. And the other thing we still need is the 1.5 kilo ohm pull up, but I have to see which port bit is that. It's PB4 needs it, because on PB3 you already have it. Okay. Am I still in frame? Yes. So you get all my bad practices here. Okay, and now maybe like this, and then we have to still connect the middle pin. Maybe let's do it like this. I'm pretty sure I can't finish this tonight on the stream, but you saw the demonstration before I took the bodge off. So in principle it's working, just have to make it a bit more pretty and durable. And then what we could also do is print a small plastic case with a 3D printer. That's designed for this form factor. Yeah, what I want to try is if I could, how long I can power it with 1 or 2 3-volt coin cells. I mean, of course, you can make it much more power efficient once everything is in place, and if you have good eyes, then you could just take the 2 Zener diodes off. You could take the power LED off, and then of course power consumption will go down. But the trade-off here was make it easy to program and live with the compromises that you get in order to achieve that. Okay, I still need a wire from the middle pin of that connector to the other capacitor. So like this. Right. So. Just thinking, this other connector was intended to be the keying output, I think. Yeah, because here we have P0 I've connected the buzzer to, and P1 I've connected the keying output to, because P1 was also the one that has the red LED on. So for the keying output I also need ground, yeah? So I could just continue here with the ground, or take it from the other side. Where does the transistor go? So the keying transistor also has to go in here somewhere. Yikes, I've already made a mess because of the buzzer. So we need no. Where's the collector? So this is emitter, basis, collector. From collector to emitter, and here the base. Yeah, maybe like this, or it's not. It's already a bit tight here, is it? I should put it maybe here. Yeah, but then the wiring is nasty. Maybe like this. Okay. And we have still another capacitor to fit in here. It would make sense to just put it across the two pins, or maybe like this. Yeah, this would work. Yeah, let me solder that in already and worry about the wiring afterwards. So from P1 I have to get to the base, which would work. And this one is the collector, and this one is the emitter. Wire down here and wire down here. Yeah, that would work. Okay, let's do it. Yeah, so if this one is the collector, then the ground pin is the other one. Okay, good. So I guess getting an idea of my component placement. So maybe first the transistor 1, 2, there's my third transistor pin here, 3, and then the capacitor 1 and 2. Good. Pretty sure I will find out if I've misoriented the transistor in a day or two. Good, so okay, let's do it like this. Let's cut this here. And this is a botch job, isn't it? It's always the how much effort do you want to spend in a one-time build? So any shorts where we should not have any? No, looks okay. Good. And now I think this was the pull up for the port bit 4, and I'm just wondering where the button should go, right? Because you also still have the button to deal with, and the button is now right in the middle, or PB0 is the buzzer, PB1 is the output. Yeah, PB2 is now right here in the middle with no space whatsoever. Great. But what we could do is here on the back side, maybe make a connector here. Here is still space. Okay, so and PB4 also has to go to plus 5 volt, which is where? Here. So maybe, yeah, right. So far for putting the connector here, because the pull-up resistor has to go here. Wow. Is it even the right pull-up resistor? No, that was the 100 ohm for the volume adjustment of the buzzer. Here I have the correct one. This is the 1.5K. Maybe I've cut this PCB a bit too tight. Huh? A few extra holes would not have been a bad idea, but okay. So plus 5 volt from here to but where do we put the button connector then? That was a bit dumb, wasn't it? Or maybe the idea was to put the button. This is not a jumper, maybe this was supposed to be the button. But I'm sure I wanted to have the 100 ohm resistor in line for the buzzer. What am I doing? Making a complete pig's ear out of myself. Okay, well, first thing first, clean up the resistor a bit and bend it properly. And then this is right, PB4 was here, so that's PB4 is here. I need, and here's the pull up. Maybe I put it here. There's not much choice. I didn't really want to have the. It was not so clever to put the ground here on this side. Maybe like this. And the 5 volt can go here and connect here to this pin of the jumper. So we go up here and then down here to these 3 pins, more or less. Good. And for the (100 ohm resistor, I can just mount it upside like this. Something like this. Whoop. Get obsessed with the radius of the upside resistor and just put it in here. Yeah, that would work. And I still don't know what to do with the button. Mind you, I could sneak it down here, and then I could have just 2 pins for the button somewhere here. That would work. Okay, good. Yeah, I'll finish the component placement and then I think I'll end the stream. I think you all got the idea. The original idea of making it easy to program without an extra AVR programmer was achieved, but there's a bit of penalty now on the building side since we need these 2 extra jumpers, but that's life. So okay, then maybe like this. Oh God, it looks terrible. So now I just have to get happy with my bending here. It looks terrible. But I have to use this dinged resistor. My parts box is empty. Not too many spare 100 ohm resistors in there. So we have to live with the ugliness. Na komm. That's not good. This is all not good. First it didn't flow and then it was too much solder. Bloody hell, I need more flux for my board here. Ah, much nicer, see. Suddenly the worst solder joint looks acceptable when you add enough flux. Okay, I think the only thing that is missing is the connector for the button, and my resistor doesn't sit flush. Come on. Okay. So like this. So these two jumpers would be the use it or flash it jumpers. This is the bridge for the buzzer to bridge this 100 ohm resistor. That's the 1.5K pull up. And what else do we need? I think I missed one more resistor for the base of the transistor, or did I imagine that? Let me quickly check on the computer. Where is my schematic? Yes, 4K7 goes to the output pin. So I need 4K7, another resistor. Let's see. In my inherited parts box, 5,000 years old components. What is this? This 4K7. Where is my LCR meter? There it is. Let's see if that is 4K7. Usually I know the color code, just not for the 1% metal film resistors. What is this? It's 3.3. Well, that makes sense. 2 orange rings, doesn't it? So that looks like 4K7. Yikes, why are all my parts so ugly? Jesus Christ. And yeah, that's 4K7. So we need this one. And two more pins for the button. Shame I don't have, still have some angled pins here. That would be nice. Here. So maybe, yeah, well, from a case, later when I put it in a case, it would be nice if the connector does not stick out at the worst place. Maybe here, then I have the ground connection already, and this pin can sneak around here and go to the button pin. That would work. Okay, let's put it there. Then we have here the pedal input, the Keyer output, and here the button. Why not? But it would be nice if I can still insert the USB connector, right? So maybe like this. Then I can still insert the USB Is that flush? Or we go even one deeper, like this. Yeah, that would also work. So not very well thought out layout, isn't it? You should never cut your PCB before you know what you want to put on. Oh well. Okay. Let's see. Here I found some old connector from my RC helicopter days. So the idea was to basically use the pins here and make that the connector for the pedal, and do something similar like here for the Keyer output and for the button input. Oops, can you see it? Yeah, like this. Okay, let's put this connector on, and we have to find a place for the 4K7 resistor. The question is, if this thing is powered by 3 volt, is 4K7 still a good resistor on the base of this transistor? I'm pretty sure I'll find out and take it out again if it doesn't work. I saw a kit for this CW Keyer on some website on the internet. What was it? HamKits.cz, something like this. And it looked like it was a low power version, not using a ATTiny85, but I think they were using a even smaller one, ATTiny84 maybe. So if you're looking for the super ultra low power variant, you can Google if that shop still exists. So port, yeah, it's PB1. Then why not put the resistor? Like this. Goes to the base here. Yep, there's not really much free space, but I have all the parts on. Okay, good. Let's solder them on, finish the stream, and then I should probably call it a day. Because if I'm fiddling too long, things just get worse. I don't know. You have to know when you have to stop. So, and now, of course, everything is falling. I need a bigger desk. So, now, can solder this pin and this pin. And cut the legs, and then we need the connector for the button. Maybe I should. Yeah, that's also the question. How thick will the case be? Yeah, no, angled connector is probably better. Yep, I'll put it here and hope for the best. And made a mess. See, it's a clear sign that I should stop. Okay. And yeah, made a complete mess. Come on, it should sit flush to the PCB. I think, yeah. I guess I'll give it a quick scrub with IPA. And call it a day. That even rhymes. Didn't solder that 100 ohms resistor in properly. Ah, now things look much better. Okay, so now let's see if I can get you a quick macro shot of this mess. So, maybe go closer. So here's my component placement. Yeah, so PB3, PB4 go to these two jumpers. Then from these two jumpers you have the one and the other pedal input with the two capacitors to ground. Ground pin is the middle one. For PB4 you have, well, or you will have, when I've wired it up, you will have the 1K5 pull up to plus 5 volt or plus 3 volt. And here the button input, the jumper to short out a 100 ohm resistor for the buzzer. And here in this area we have the 4K7 resistor which goes to the base of the 2N2222 transistor. And between collector and emitter we have the 10 nanofarad capacitor here as well. And this will be the Keyer output. Okay, so the only thing that the genius that I am, have not done is where to connect the power to. Because, yeah, there's basically two options. Now I realize my mistake. No, it's fine, sorry. Yeah, here you have a 7805 regulator on. It's not a low power variant, not a LDO variant, so you can power it here in theory with whatever, plus 12 volt to ground, or you can give it here on the 5 volt input, you can give it 5 volt or even just 3 volt. So the question that I was asking myself, where do I connect the power? That's the other, the next connector that I've forgotten in my super cramped make it up as you go along design. So power connector could be on this side. Oh well, I'll figure it out. Time to scrub this thing with IPA and call it a day. As simple as it is, if you want to put it on in a small space, it becomes a bit cramped. So I think, yeah, if I would have given it 5 millimeter here on these two sides, and on this side it would be all a bit easier, but yeah, miscalculated when I started this. I thought it's, yeah, you can hear from my saying I'm not entirely happy with this build. Yeah, but I already had my doubts when this thing showed up, and I realized that I have real problems sharing the USB with the pedal input. So yeah, there's also a Digispark Pro. So in theory, you could probably get a Digispark Pro, but you might need to adapt the software then. I'm not sure what. It's using a different AVR, and the ATTiny85 firmware is very well. It's AVR, so I think porting from one AVR to the other is not so hard, but at least the low-level things that are configured, like timer 0, timer 1, CPU frequency, and all the dividers, you have to maybe adapt that. So yeah, as said at the beginning of the stream, maybe a AVR Pico would have been the better choice, but okay, good. I think I'll close the stream for today. Yeah, my channel is anyway on the decline. Not very successful with this YouTubing. So, oh well, maybe somebody finds it interesting in the next week to look at this, and yeah, put a comment below if you want me to upload the adapted firmware. I just have to clean it up maybe a bit more, then I can push it to GitHub, and then you can find it as one of the forks of the ATTiny85 CW Keyer. Okay, so that was it for today. Have a great week, and until next time. Bye.